Alright, so in this video I just want to demonstrate how I'm cutting out with my Wen rotary tool, aka Dremel, how I'm cutting out my stainless steel tubing into small sections or small length cuts, 1 millimeter to 2 millimeter roughly length, in order to create plain bearings. Basically, you have a smaller tubing and a larger tubing. The smaller goes inside the larger and forms the inner race of the bearing, and then the larger tubing forms the outer race. The tubing I bought on Amazon for about $5 per tube, and I bought 3 millimeter OD, 1 millimeter wall, 250 millimeter length, and that's the inner race tubing. And then I also bought 5 millimeter OD, 0.8 millimeter wall, 250 millimeter length, again for $5 as stainless steel tubing. So the 5 millimeter total OD with 0.8 millimeter wall gives it a if you add the two walls, it's 0.8 plus 0.8, so that would give you that would actually give you 1.6 millimeters off the 5, which brings you to, that gives you 3.4 millimeters as its total inner diameter. And we bought 3 millimeter OD as the inner bearing part, the inner race. And this is 3.6, so we're going to have 0.6 millimeters of slop actually. Now, that might be too much slop. I might want to go with less slop than that. So I also did buy, just to experiment, a 5 millimeter OD 1 millimeter wall stainless steel tube, which would bring it 5 minus the two sides of the wall would make it 5 minus 2 millimeters, would be exactly 3 millimeters. So then the inner bearing race would have zero slop. You wouldn't be able to get it in. So in order to actually get it in, you'd have to either sand down the outside of the inner bearing, or you'd have to sand the inside of the outer bearing from the inside to widen it to give enough slop to actually be able to insert the inner part of the bearing without it just scraping and being unable to turn. So you need to have a certain amount of play so that it can actually turn, and that would give zero play. So that would enable me to customize the amount of play to however much I want based on how much sanding I do. I could put the stainless steel tubing into a drill and then just use like some plumbing copper cleaning sandpaper and just wrap it around and then turn on the drill, and it would just sand that inner race over and over and over until I shut it off, and then I could test the fitment, and I could like really customize the fitment that way. But that's just added steps and more work, so I'm leaning toward just sticking with the 0.8 millimeter wall, which would give, like I said, 0.6 millimeters of slop. And that slop is a little extra space, in my opinion, to put bearing grease or whatever. So it may not be a bad thing to have the ability to fit more grease in there, which would enable it to re-lubricate itself more times. So that might be a good thing, but I'm not an expert on this stuff. I don't know. Here you can see, right here, you can see the amount of slop between the two. So this is the outer race, and this is the inner race. That's the amount of slop that the grease could hang out in. This is 5 millimeters diameter. So that's your actual plain bearing. That's it, completed. I just need to grease it and then add on the plastic discs on either side, sandwiching the bearing in order to have it be a pulley for us. I cut these to about 1 millimeter lengths. You can see a bunch of these inner bearings I cut over here. And and then some more outer bearings I cut here. So these are the final cuts, and I'm basically, this video is going to be showing how I did those cuts. It involves cutting with the Dremel and then filing. Okay, so here you can see I get the Dremel diamond cutting disc lined up with this little alignment box I made out of PCB prototype 5x7 boards. I cut a little notch for where the screw is that locks down the diamond cutting disc so that I could get the disc nice up and snug against the edge of the prototyping board. I keep about a 2mm distance between the edge of the board and the cutting disc, and I just hold it in place by hand right now. I could create some type of locking mechanism to really lock down the Dremel so you don't even have to hold on the Dremel. You could have both hands free to guide the stainless steel tube perfectly, but I'm just having to manually keep everything really lined up the best I can. It's a very manual process the way I have it, because it's not really got the proper guides and stuff right now. And actually, speaking of which, if you look here, we've got a design for you put the Dremel on this, and then the tip of it goes on that, and then this thing locks over and snaps down, locking the Dremel into place on a hinge over here. And then you've got this thing which could guide your stainless steel tubing into the cutter, and then the Dremel cutting wheel would come through this. The tubing would slide this way, and then it would hit this adjustable end stop here. It would bump into this, so you would get the exact same length cuts every time by adjusting where the end stop ends, and then the little screws on the bottom could screw it in. The bolt would press into the underside of this table and lock in this end stop piece on both sides. You have a screw, and that would lock this in, so then the stainless steel tubing would be only able to go the exact same distance this way from right to left, and then it would have a perfect perpendicular cut. This would keep it perpendicular through this thing. And this thing would slide through this channel, and if you could create an elongated one to go through the channel, then this would not be able to rotate right and left. It would always stay exactly perpendicular. So that would be an improvement to what I showed here. But making this sliding adjuster and this end stop would be two things I could do to improve my current real quick setup. But what I realized is I was basically trying to make this whole thing out of prototyping board. I realized, well, wait a minute. I don't have to make all this extra stuff. I'm kind of just impatient just to get started with cutting for now. And with my magnification visor I wear and my eye-hand coordination, I'm able to give pretty good accuracy even without these aids, which help you. I just basically eyed everything. Just eyeing it gives you, with the magnification, gives you good enough accuracy with my skill in eye-hand coordination and stuff to not need these basic aids that would make you even more precise. But if I were to want to make more and more and more of these, it would be a luxury to have these extra features to really lock down the Dremel properly and lock down your orientations and getting everything perfectly flush and parallel and whatever to a fine degree would be really nice. But by doing it freehand like I'm doing, I'm able to get decent results and then use filing and sanding methods to perfect it after the fact, which is more work. But I just wanted to get going quicker because we're still kind of prototyping here, and so I didn't want to spend any more time making this board. But basically what you see in the video is this thing way simplified. But this side is something I downloaded actually from, and I modified, I customized it, but I downloaded like a base model of this from like a free 3D printing website of 3D models. It was a free download, and I modified it for my purposes to what you see here. And I could actually 3D print this whole thing if I want to. And that might be a better way, but that would be like, I don't know, like 12 or 15 hours of printing, and you'd have to break it up into multiple prints. And it just seems like 3D printing is just too slow for me to build something like this when I could make it much faster just with super glue and those 5x7 prototyping boards. I could just fabricate all this a lot faster, I think. So I just quickly made a minimalistic, bare bones version of this concept that you see in my video, and it works out for me okay for now. But these are improvements I can do in the future. So let me continue. As we get to the end here, as soon as I notice the piece start to bend back, because it's so thin, that's when I stop so it doesn't go flying off somewhere. I don't want to lose it. So I stop right as it begins to bend on its own. And then I just wiggle it back and forth a handful of times and it's able to come off. That's all about not losing it, basically. It's so easy to lose these parts, so I tuck it into the fold of my shirt like that so I don't lose it. Now, for this part, I just smooth out and get everything flush again because that kind of is a very imperfect cut. So I just flush it out using the sanding disc as a flush maker surface because it needs to be flushed for the next one I make. So basically, what I'm doing here is just preparing for the next one. I'm creating a nice flush face that's as perpendicular as I can get it by eye. And this is very imperfect just because everything's by eye, but it's I'm able to get, I think, like 0.15 millimeters accuracy by eye, which is probably quote unquote good enough. And like I said, you can sand from there with little nail files. So it's kind of like maybe I don't even need to get too fancy with it, but if I make the features we talked about earlier with that 3D model I showed you guys, if I make that, that's going to make my results more consistent and save me time on the sanding part. And so for mass manufacture of many, many, many of these, that will be a big time saver. And I'm going to have to make a lot of these. At least 3 per motor we're going to have to make. So that's 2 cuts per, so that's 6 total cuts per motor, 6 pieces per motor. And we're probably going to have to do like I don't even know how many motors, because actually what's going to happen is when I switch to bigger motors, I might need to make like bigger pulleys too. Not sure how that's going to play out. So I'm not sure, but it's going to be. I mean, let's just make up an estimate. Let's say like just to make the ones that I have to make before the robot takes over making the stuff for me. Since, like I said, once I finish the robot's right arm and head, he'll be able to start working for me to make the rest of his own body. So just to make the right arm and head, I probably need to make like maybe 40 motors and so 40 down gearing systems. Each one requires 6, so 6 times 4. That's 240. But yeah, 240 cuts. I already did like 10 cuts, or like yeah, maybe about 10 cuts in one day. So that's 24 days of cutting. That's a lot of cutting. 24 days of cutting, but only working on it for like a couple hours a day. Um, so yeah, I think it would be worth then making the 3D model features I showed you guys to make more accurate cuts and kind of save time with the filing stuff. So I probably will go ahead and do that because I have to do so many of these cuts. Here you can see I'm just getting the end more flush and getting rid of all the burrs and stuff. I ordered more nail files. That one pretty much butchered already. I'm using it so much. These are surgical pliers I'm using here to grab onto it, be able to work on it. Very convenient for this because you can snap it off and it holds a lot of pressure on it. I shaved off the part of the messed up part when you have to wiggle it to remove it. It leaves a decent amount of metal there from when I snapped it off. And that's the part I need. I needed to remove enough material to justify getting out the Dremel again. And now that it's pretty close to being perfect, now just going between the file and the other file, the needle nose file and the nail file, I'm able to get both faces way more flush.
cut out these little stainless steel tubes to like between like 1 to 2 millimeters thickness, and one tube goes inside the other tube like this, and they just rotate in there. And so these are custom bearings I'm making, and I had to build my own little bearing making table out of like little circuit boards. So that's the exact height of the Dremel. So I made it's like a cutting table, and I'm able to use the little lines on here to like make sure that I have this not turned the wrong way, so I can like line it up, which is kind of cool. I did order a 2-inch miter saw, which can potentially do a good job of this as well, but this was my original plan, and it's actually turning out pretty good. Now that I got a really good Dremel. I was using a crooked Dremel, which had the blade flying around everywhere, but this Dremel's really not broken. The other one's basically broken, so that's why I wasn't working. So I got this one working. Today, I think I got this working. I was like, oh, this is great. So yeah, it's exciting stuff. We've pretty much got like almost 2 done. I want to make a bunch though while I got this all out. Yeah, it's funny. I'm doing like precision machinery without like quote unquote proper tools like a lathe or whatever. But this stuff is actually making pretty precise parts. I'll take some close up photos with my iPhone and post it on socials. Notice I got safety glasses and a visor on for like. Hey, God, Slinky. Um, the visor helps me see better, and also has a light on it and magnification. And I got safety glasses under it, since there are little metal shards flying around. Did you order the boards you're working on? No, I did not. Well, I tried. Actually, no, I did order it, and I canceled the order because they charged me like $400 just to make like the 5 little boards like this big. So they're gonna do like almost $100 a board for something this small. And I'm like, dude, okay, now you're just crossing the line. Like, I can literally justify making that myself and making like $15 an hour to do so. Like this is done by machines. They're just overcharging at that point. But it's not always going to be that way. It's just if you have like, if they think they said that because the circuits weren't all touching each other, that I'm doing like multiple circuit designs. They try to charge me per design, even though this was all part of my motor controller circuit. But I was going to be taking little fragments of it and overlaying it onto other fragments of it and connecting it to all the parts, and it ultimately all was making one circuit, but they saw it as being multiple circuits for multiple different projects. Even though I didn't tell them that, they just made that assumption and charged accordingly. And I told them that's not true, and they don't care. So it was a stalemate, and they were going to refuse to work with me on it and just charge me like a fortune. And I wasn't going to have that. I'm not putting up with it, so I just canceled. This is a cool little tactic I did here too. You put the little bearing piece on your nail file, and then you use another file which like grabs it, and then you just move it back and forth. Also, this makes it flat on the top so that the bottom's irregularities, only the high points get shaved. So it's like, you know the saying, between a rock and a hard place? That's pretty much what we're doing here to this bearing. It's like 2 flat things. They're going to make a flat thing if they're both coarse, and they're both going parallel. So I try to keep both as parallel as possible, and I use my stomach fat as a pressure plate. That's why I have to eat a lot, guys, because it helps with bearing making. The fat is necessary for bearing making. It gets you a bigger table. I need a bigger work table. Gotta order some more donuts. By the way, when I'm not streaming, I usually listen to something. I put in silicone earplugs for this, and I then shove my Apple iPhone style earbuds, auxiliary style headset, into the silicone. You can still hear. You just shove it in there. Now, the thicknesses of these are going to be kind of random. I'm just doing it by eye, so they're going to vary. But my thought is if I make a bunch of the smaller ones, and then or a bunch of the inner races, which is this one, and then a bunch of the outer races, which is the other one. If I make enough of them, I'll be able to mix and match to find two that pair up to be the same length. So I don't have to worry too much about length because eventually we'll just be able to match to another one. I happen to make that length. Does that make sense? Well, the taper on my index finger is because um, the tubing gets so hot while I'm cutting it. It's kind of singeing that finger. And this keeps the heat off the finger so I can bear it a little better. I figured I pretty much have to stream showing how I made this. Because, like, I don't think people would even believe I could do it like this if they didn't see it with their own eyes. Like, making something this small by hand is kind of weird. I mean, I guess jewelers do it, but not many DIYers get down to these types of scales, so do I file down the pliers? No. This is the bearing for the hinge of the mini trash can? No. This is the bearing for down gearing the brushless DC motor for the down gearing pulley system for the index finger of my robot. That's a lot of fours. Bearing for the pulley for the down gearing system, for the Archimedes down gearing pulley system for the humanoid robot, specifically for the Able robot. And this type of bearing is called a plain bearing because it's not a ball bearing, it's just plain. This is pretty much how like all bearings were back in like the Roman days, Roman Empire. They didn't have ball bearings back then. And so they obviously were. And they're stronger than ball bearings because they don't have like little balls that can be squashed under the heavy forces involved. By the way, I stop when it looks like this. Uh, cool. It's like literally just a paper thin hinge that's left. Looks like I'm making a little washer, but it's very. Five little ones, two big ones. So I guess this is just going to rinse repeat a lot. So I think I will end it here. That'll give me less editing work, and I'm just going to keep going with this one, just like some audio I can listen to. Peace out, guys.